So today we're going to begin actually our work in the main math workbook that we're using, or the math system we're using, and it says EM because that stands for Eureka Math. Eureka Math is the name of the math system or the math book that we are using this year primarily, okay? So that's why it says EM, Eureka Math, lesson 1.1. We talked about what 1.1 means. That means chapter 1, in this case it's lesson 1, chapter 1, lesson 1, okay? So tomorrow's lesson is going to say EM, what does that stand for? Eureka Math, lesson 1.2. What does that stand for? Chapter 1, lesson 2. Very good. And your learning goal today, by the end of math today, you should be able to demonstrate or show me that you can use a place value chart to show how adjacent place values are related. Let's talk about that word adjacent. That just means people that are place values that are next to each other. Adjacent means next to each other. So Luke and Rupa are adjacent to each other. Charlotte and Shivani are adjacent to each other. Charlotte and Sawyer are also adjacent to each other. Does that make sense? Point to someone who's adjacent to you. Very nice. So in the place value chart, if you have the ones place, what place value is adjacent to the ones place? Everyone? The tens. Very good. So today you're going to be able to use a place value chart to show how place value positions that are adjacent or next to each other are related. As you know, a place value chart is a chart that shows you the different place values. Last week we looked at a place value chart that started with the ones, right? And what place value position is adjacent to the ones again? Tens. And what's adjacent to the tens? And we said that these three made up one period, yes? What period does that make up? The ones period. Very nice. Then we got into a new period. What's the next period called? Thousands. And included the thousands, the 10,000s, and the 100,000s place. Yes? Then we got into a new period. Oops. What's the new period called? Millions. And this one only shows the millions, but what would be next? What would be adjacent to the millions? 10 millions. Very nice. And what would be adjacent to that? 100 millions. We know that we can keep going that way. Very nice. Now I'm here to show you that there are also digits to the right of the decimal point. The decimal point shows that it is just part of a whole. Okay, so there is the first, this is another period right here, okay, and this position is called the tenths position, this is the hundredths, and this is the thousandths. What's the difference between the hundredths and the tenths and the thousandths compared to the tens and the hundreds and the thousands? What difference do you notice? Talk at your table group. So we noticed that we were adding one more zero each time we were moving to the left. That means each time we're moving one place value to the left, the value is getting bigger. How much bigger? Each time we move one place value over to the left like this, or from here to here, or from here to here, from here to here, it's getting 10 times bigger. That, conversely, we can think of it the other way. If I'm going this way, is it getting bigger or smaller? So when I move from right to left, it's getting 10 times smaller. Okay. That means if I want to fill in this part over here, this place value, this missing one here, is it going to be bigger or smaller than the ones? How many times smaller?
10 times.
So you're telling me this is 1/10 the size of this?
Yes.
So that means that this place value here is the tenths place. What about this next one over here? Is this one going to be bigger or smaller than the tenths? Smaller. How many times smaller?
10.
So it's the hundredths, and you can write it like this, hundredths place. This last place over here, is it going to be 10 times bigger or 10 times smaller?
10 times smaller.
So what's 10 times smaller than 100th? 1,000th. So this is the thousandths place. If I have 1/10, and I want to split that 10 into ones, how many ones does it take to make 1/10? If I give you a $10 bill and I say, hey, can you turn that $10 bill into $1 bills? How many $1 bills do you need? 10. It takes 10 ones to make 1/10. So if I'm changing, if I want to draw one dot in the tens column, and then if I have only one dot in the ones column, how is that value changing? If I move my dot from the tens column to the ones column, is it getting bigger or smaller? If I draw one dot, hold on. Let me erase this so I can show you. If I draw one dot in the tens column, what's the value of that dot? 10. Okay. Now if I move that dot into the ones column, what's the value of that dot now? Did the value get bigger or smaller? What was the value before?
10.
What's the value now?
1.
Did that get bigger or smaller? By how much? It got 10 times smaller, didn't it? If I have one dot in the 10,000s column, and now I move it to the thousands column, did it get bigger or smaller? Did it get smaller by how much?
10 times.
So when I move a digit from the left to the right, it gets 10 times smaller. That's the same thing as saying we're dividing by 10. Yes? Okay. So if I have 400,000, but then now I move that 400,000 to become 10,000s or 40,000s, did that value get bigger or smaller? Because I divided by 10. Okay. So in your place value chart, let's try this problem. If I have 1 million and I want to divide it by 10, how can I write 1 million? Let me show you. Ooh, hold on one sec. To write 1 million, I just need to put a 1 in the millions column, yes? And then I would fill this in with zeros. Is that 1 million? If I want to divide that by 10, how do I need to move those digits? Do I move it to the left or to the right? I do. I need to move it to the... Once again, if I have 1 million and I move it to the right one, that's the same as dividing by 10. Now what number do I have?
100,000.
Now I have 100,000. So 1 million divided by 10 is 100,000. Let's try this example down here. If I have 1, I'm going to write a 1 here. And if I want to divide it by 10, I need to move it to the... And now my answer is 1/10. So 1 divided by 10 is 1/10. We just said if we need to divide numbers, we have to shift them to the right. Now, if I want to make this 4 10 times bigger, do I need to move it to the left or to the right? Left. So I can show it by going like this. I move it 1 time to the left to multiply it by 10. And now my 4 is in the tens column. So how can I show that it's worth 4 tens? I need to plug in a placeholder 0 in the ones. So what's 4 times 10? 40. Okay. Let's try this example in blue. I have 4 tenths. So that means that now the 4 is in the tenths column. Yes? Do you agree? And I want to multiply it by 10. Do I need to move it to the left or to the right? How many columns? 1. So now my 4 is in the ones place. So what's 4 tenths times 10? 4. Very good. Okay, let's try one more example. This time I have, I'm going to move this out of the way. Very good. Okay, this time in red I have 4 thousandths. So that means my 4 starts out in the, what column? Thousands column. And if I have to move it, and don't forget we need these placeholder zeros, okay? If I want to multiply it by 10, I have to move it to the right or to the left? How many spaces? So it looked like that, right? That's how it would shift. The digits would shift to the left, but I can show it like this. All these digits are shifting, okay? This one, I don't really need to because it doesn't have value, but that's okay. So what is the answer? Now my 4 is in which column? So the answer is 4 hundredths, and I can write it by writing 0.04. So this shows us that in order to multiply by 10, we have to shift the digits to the